Hello everyone. Today I'll demonstrate how to find the inverse of a matrix using the adjugate method, one of the important topics in linear algebra. Before we begin, let's ask a small question. Why do we find the inverse of a matrix? Finding the inverses of matrices is used in various fields such as solving complex linear equation systems, rotating three-dimensional objects in computer graphics, and even in encryption algorithms in cybersecurity. So, what we will learn today is not just an exam question, but one of the basic building blocks of the digital world. Let's look at the question now. The question gives a 3 by 3 A matrix and asks us to find the inverse of this A matrix using the adjoint matrix method. The first step to solve this is to find the determinant. There are two methods to find the determinant of 3 by 3 matrices. First is the Saris method. We start by writing the 3 by 3 matrix in a regular way. Then we take the first two rows of the matrix and add them to the bottom, or we take the first two columns and add them to the right side of the matrix. Here, let's take the first two rows and add them to the bottom. Then we multiply the three full diagonals going from the top left to the bottom right and add the resulting three products together. So 2 times 5 times 1 plus 3 times 2 times 4 plus negative 1 times negative 1 times negative 2. Then we multiply and add the three complete diagonals descending from top right to bottom left. So 4 times 5 times negative 1 plus negative 2 times 2 times 2 plus 1 times negative 1 times 3. Finally, we subtract from each other. When we do these operations, 10 plus 24 minus 2 minus negative 20 minus 8 minus 3. From here, 32 minus negative 31 equals 63. The result, which is 63, is the determinant. The second method is cofactor expansion. Here we choose a row or column. Let's choose the first row here. We multiply each element in this row by its cofactor. The cofactor of the Aij element in the ith row and jth column of matrix A is denoted by Cij and is calculated as minus 1 raised to the power of I plus j times Mij. Here, Mij is a minor. This means it is the determinant of the submatrix that remains after the row and column containing the Aij element are deleted. If we expand the determinant according to the first row, the determinant A equals a 1 1 times C1 1 plus a 1 2 times C1 2 plus a 1 3 times C1 3. If we replace the numbers and perform the calculations, it becomes 2 times 5 minus negative 4 plus 1 times 3 minus 2 plus 4 times 6 minus negative 5. From here, it becomes 2 times 9 plus 1 times 1 plus 4 times 11. When we do the multiplications, it becomes 18 plus 1 plus 44 equals 63. We found 63. What would happen if the determinant was 0 here? If the determinant had been 0 here, the matrix would not have an inverse, but because the determinant is different from 0, it does have an inverse. Let's move on to the second step now, finding the adjunct matrix. To find the adjunct matrix, we need to find the cofactor matrix. To find the cofactor matrix, let's first calculate the cofactor of each element. What was the formula for the cofactor? In the third expository, the cofactor formula for the element Aij in the ith row and jth column was negative 1 to the power of I plus j times Mij. C11 equals negative 1 to the power of 1 plus 1 times M11 equals 9. C12 equals minus 1 to the power of 1 plus 2 times M12 equals minus 1. C13 equals negative 1 to the power of 1 plus 3 times M13 equals 11. Try doing the second line yourself first. C21 equals minus 1 to the power of 2 plus 1 times M21 equals 9. C22 equals negative 1 raised to the power of 2 plus 2 times M22 equals 6. C23 equals minus 1 to the power of 2 plus 3 times M23 equals minus 3. C31 equals minus 1 to the power of 3 plus 1 times M31 equals minus 18. C32 equals minus 1 to the power of 3 plus 2 times M32 equals 16. C33 equals minus 1 to the power of 3 plus 3 times M33 equals 13. Now let's create the cofactor matrix that we denote by C. Next, we need to find the adjoint matrix. The adjoint matrix is the transpose of the cofactor matrix. We find the adjoint matrix by interchanging the values of I and j in the elements Cij of the transpose matrix, making it Cji, that is, by swapping the rows and columns of the cofactor matrix. Finally, we need to find the inverse of the A matrix, which is our main goal. What is the formula for finding the inverse of a matrix with its adjoint matrix? The formula is that the inverse of A is equal to 1 divided by the determinant of A multiplied by the adjoint matrix. When we substitute the values we found and multiply by the determinant of the matrix, we find the inverse of L. Now we have found the inverse of A, but how can we be sure of its correctness? To check its correctness, we can multiply the inverse of A by A. The result of this multiplication should give us the identity matrix. To multiply matrices, the number of columns of the first matrix must be equal to the number of rows of the second matrix. Since both matrices are 3 by 3, this is satisfied. When performing the multiplication, you multiply the elements of the rows of the first matrix with the corresponding elements of the columns of the second matrix and add up the results. In order I1 1 equals 1, I1 2 equals 0, I1 3 equals 0, I2 1 equals 0, I2 2 equals 1, I2 3 equals 0, I3 1 equals 0, I3 2 equals 0, I3 3 equals 1. This gives us the identity matrix. That means the matrix we found is the inverse of A. Thank you so much for watching my video. If you have any questions, please leave them in the comments. See you later.